Hello student, now we will discuss ray optics, refraction, the refractive index of a medium. Refractive index, the ratio of velocity of light in vacuum to the velocity of light in medium is called refractive index of medium. It is denoted by mu. It is denoted by Greek letter mu. So mathematically, mu is equal to C upon V, where C is velocity of light in vacuum and V is velocity of light in medium. So this is the first definition of refractive index. Now second, to explain the second definition, let lambda naught and lambda are wavelength of light in vacuum and medium respectively, as during refraction the frequency of light remains same. Therefore, C is equal to F lambda naught and V is equal to F lambda, where F is frequency of light. Therefore, mu is equal to F lambda naught upon F into lambda, because frequency remain same and F cancel each other. Therefore, we get mu is equal to lambda naught upon lambda. So second definition is therefore refractive index of a medium is also defined as equal to the ratio of wavelength of light in vacuum to that of in medium. This is the second definition of refractive index. Now third one, refractive index of a medium is also defined as equal to the ratio of sine of angle of incident to the sine of angle of refraction. Let AB is the surface separating two medium, rare medium A and denser medium B. So this is the normal N dash. From point P, a ray of light strike the surface at point O is the incident ray, which makes an angle I with the normal. Now as ray of light is entering from rare medium to denser medium, therefore it will bend toward the normal, and OQ is the refracted ray of light, which makes an angle R, angle of refraction with the normal. Therefore, A mu B, the refractive index of medium B with respect to medium A, is equal to sine of I upon sine of R. A mu B is equal to sine I upon sine R, where I is angle of incident and R angle of refraction. And the A mu B is the refractive index of medium B with respect to A. So this is the third definition of refractive index. Now fourth one, the refractive index can also be defined as equal to the reciprocal of sine of critical angle. So mathematically, A mu B is equal to 1 upon sine C, where C is the critical angle when ray of light move from denser medium B to rare medium A. The incident angle in the denser medium B, for which the angle of refraction become equal to 90 degree is called critical angle. Again, suppose AB is the surface separating two medium, rare medium A and denser medium B, and this is the normal to the surface N dash. From point P in the denser medium, suppose a ray of light strike the surface at point O is the incident ray of light, and suppose it makes an angle with the normal equal to C, the critical angle. Then the refracted ray of light becomes parallel to the surface separating two medium, that is OQ is the refracted ray which is parallel to the surface separating two medium, or the angle made with the normal is equal to 90 degree. Therefore, if a ray of light enter from denser medium to rare medium, it bends away from the normal, then at a certain incident angle, the refracted ray becomes parallel to the surface separating two medium. That is, the angle of refraction becomes 90 degree. This incident angle in the denser medium, that is C, for which the angle of refraction becomes equal to 90 degree is called critical angle C. Therefore, A mu B is equal to sine 90 degree upon sine C. Now, because sine 90 degree is 1, therefore, A mu B is equal to 1 upon sine C. Now, real depth and apparent depth. So, this is the denser medium and O is the point at the bottom. From point O, a ray of light strike the surface, other surface, opposite surface at point B, and at point B, suppose NM is the normal to the surface, and suppose OB makes an angle R with the normal and M, because ray of light is entering from denser to rare medium, therefore it bends away from the normal, and BC is the refracted ray of light. It makes angle I with the normal. Other ray of light from point O fall normal to the surface at point A. Now, because the incident angle is 0 degree, therefore angle of refraction is also 0 degree, and ray of light moves undeviated along AD. Now, both refracted ray of light appear to be coming from point I, so I become the virtual image of point O. That is, when we see from the above, we see the point O at point I. Now, this is the real depth of the denser medium D0, and this is the AI, the apparent depth which we observe from this upper point. This is the apparent depth of the denser medium. Suppose angle AOB is angle number 3 and angle AIB is equal to angle 2 and angle MBI is equal to angle 1. Now, in triangle OAB, this is the triangle OAB. Tan angle 3 is equal to AB upon OA. Now OA is parallel to MB, therefore angle 3 is equal to angle R. Angle 3 is equal to angle R. These are the alternate angles. Therefore, we get tan R is equal to AB upon OA. Put this question number 1. Similarly, in triangle IAB, tan angle 2 is equal to AB upon IA. Height upon base. Put this question number 2. But angle 2 is equal to angle 1. Again, these are alternate angle. And angle 1 is equal to angle I. Angle 1 is equal to angle I. These are the vertical opposite angles. Therefore, angle 2 is equal to angle I. Put in question number 2. So we get tan I is equal to AB upon IA. Put this question number 3. Now dividing question 3 by question 1, we get tan I upon tan R is equal to OA upon IA, because AB and AB cancel each other. If angle I is very small, therefore angle R is also very small, because angle R is less than angle I. Now, because tan angle I is nearly equal to sin I, and tan angle R is nearly equal to sin R. That is, if angle I is very small, then angle R is also very small. Then tan I is nearly equal to sin I, and tan R nearly equal to sin R. Because if theta approaching 0, then tan theta nearly equal to sin theta, nearly equal to theta in radian. Therefore, OA upon IA is equal to sin I upon sin R, implies D naught upon D is equal to sin I upon sin R, because OA is equal to D naught, the real depth, and IA is equal to D, the apparent depth. But sin I upon sin R is equal to mu, the refractive index of denser medium, by Snell's law. Therefore, D naught upon D is equal to mu, implies mu is equal to real depth upon apparent depth. Therefore, the fifth definition of refractive index is, the refractive index can be defined as equal to the ratio of real depth of a medium to apparent depth. So this is the fifth definition of refractive index. Now, normal shift. The shift in position of the object when observed through a glass sheet is called normal shift. So from the diagram, the object O appear at point I. Therefore, the normal shift is equal to OI and is given by OI is equal to OA minus AI. Now OA is equal to D naught, the real depth, and AI is equal to D, the apparent depth. Therefore, OI I is equal to d naught minus d. Now because refractive index is given by mu is equal to real depth upon apparent depth, implies mu is equal to d naught upon d, or we can find d is equal to d naught upon mu by rearranging the apparent depth d is equal to real depth d naught upon refractive index. Therefore, OI is equal to d naught minus d upon mu. In the right hand side, we can take d naught common. This implies equal to 1 minus 1 upon mu within the bracket into d naught. Now within the bracket, take LCM, we get is equal to mu minus 1 upon mu into d naught. Hence, normal shift OI is given by OI is equal to mu minus 1 upon mu into d naught, the real depth. This is the formula to find the normal shift when object is observed through a glass sheet. Now important point. First is the refractive index mu depends upon pair of media, that is it depends upon two medium or color of light, that is wavelength of light, and temperature. Mean the refractive index of a medium with respect to other medium depends upon the two medium in which ray of light enter from one medium to other medium, and color of light, that is wavelength of light, and temperature. As temperature of medium increases, the refractive index decreases. Higher is the refractive index of a medium, and optically denser is the medium. That is, if refractive index of medium is large, then that medium must be optically denser, and lesser is the velocity of light in that medium. So these are the important points for refractive index of a medium. Thank you very much.